Gel electrophoresis is a widely used technique with many applications in biochemistry, molecular biology, and forensic science. It is a method used to separate biological macromolecules, usually proteins or nucleic acids, according to their electrophoretic mobility. A macromolecule's mobility through a gel is dependent on its length, conformation, and charge. Proteins are often separated through a method known as polyacrylate gel electrophoresis, or SDS-PAGE for short. SDS is an anoxic detergent that is added to coat protein samples with a negative charge. The proteins are then able to travel through a polyacrylate gel towards the more positive electrodes at different rates depending on their molecular weight. Polyacrylate gels are ideal for protein separation, as they are electrically neutral and hydrophilic. The matrix does not interact with the samples and has a low affinity for protein stain. Polyacrylate gels are comprised of two parts. The top part is known as the stacking gel, and the bottom part is known as the separating gel. The gels differ in their pH and amounts of acrylate. The purpose of the stacking gel is to line up the samples so that they enter the separating gel at the same time. The separating gel has more acrylate and is capable of delaying the movement of proteins. Gels can be hand-casted in lab or purchased. The gel is then placed into the electrode assembly. It is clamped and put within the gel electrophoresis chamber. It is surrounded by 1 times running buffer, and this is to facilitate the electric field. All samples should be previously prepared with their protein concentrations measured, and this is so that each well contains the same concentration of protein. Samples are mixed with SDS buffer to coat the proteins with a negative charge, and DTT, which is a reducing agent. They're also boiled for a short amount of time to disrupt the tertiary structure of the protein. The samples are then loaded into the wells of the gel using a micropipette. And they're loaded alongside a molecular marker with known concentration protein sizes. Once all of the wells have been filled, the lid is then replaced. And the unit is run at 150 volts for an hour or until the protein samples reach 1/8 of the bottom of the glass plate.
One hour later.
After the electrophoresis is complete, the lid is removed. The buffer is discarded. And the gel is then transferred into a transfer solution such as methanol. The gel is now ready to be stained so that the proteins can be visualized, and this can be done through a method of silver staining, which deposits metallic silver on the surface of the gel in the areas where the proteins are located. Silver staining can be done on your own and in lab, or it can be purchased through pre-made kits such as the ones sold by BioRad. Visible bands may be compared to the known molecular markers to determine their relative size and punitively identify the proteins. The bands may also be extracted and sent out for further quantification through laboratory techniques such as mass spectrometry or Western blot analysis.